Welcome to my channel Amateur Radio Universe. Today I am going to talk about an important circuit in radio electronics called the LC circuit. It is also known as the tune circuit, the tank circuit, or the resonance circuit. An LC circuit is an electrical circuit which consists of an inductor and a capacitor connected together. The letter L represents an inductor or a coil of wire, and the letter C represents a capacitor. The circuit forms a resonance circuit that stores energy and resonates at its resonant frequency, which is determined by the value of the inductor and the capacitor. Its function is similar to a tuning fork. Working of an LC tank circuit. An LC tank circuit works by storing electrical energy alternately in a capacitor and an inductor. The capacitor stores energy in the form of an electric field or charge between its plates depending on the voltage across it, whereas an inductor stores energy in the form of a magnetic field around it, depending on the current through the inductor. When an inductor is connected in parallel to a charged capacitor, the voltage across the capacitor will produce a current through the inductor that builds up a magnetic field around it. The voltage in the capacitor drops to zero as the charge is used up by the current flow through the inductor. At this moment, the energy is stored in the inductor as a magnetic field and induces a voltage across the coil as it opposes the change in current through it. The induced voltage across the inductor creates the current to flow across the discharged capacitor with a polarity opposite that of its previous charge. The energy required by the capacitor to charge is drawn by the magnetic field across the inductor. The current flow stops as the magnetic field collapses and completely dissipates. The capacitor is now charged with a polarity that is opposite and at a strength lesser than its previous charge. In the next cycle, discharging of the capacitor occurs into the inductor, inducing a magnetic field across the coil with a current flow opposite in direction to the previous one. The charge flows, oscillating between the capacitor plates and the inductor coil until it finally dies out completely. There is energy flow back and forth until the internal resistance of the circuit, such as the resistive losses of the inductor and the dielectric losses of the capacitor, dampens the oscillation. Frequency of the LC tank circuit. When an LC circuit is driven from an external source at an angular frequency, resonance happens when the inductive and capacitive reactance are equal in magnitude. The frequency at which this equality of inductive and capacitive reactance in that particular circuit is called the resonant frequency. The resonant frequency in Hertz is Fr equal to 1 by 2 pi the root of LC. Applications of LC tank circuit. 1. LC circuits are used for generating signals of a particular frequency, such as oscillators, signal generators, etc. 2. It is used in selecting a specific frequency from a band of frequencies, where it is commonly used as bandpass filters and tuned radio frequency amplifiers in radios, television receivers, communication equipment, etc. 3. LC circuit acts as an electronic resonator in oscillators, filters, tuners, mixers, discriminators, etc. in various gadgets. 4. The parallel resonance circuit is used as a load impedance in RF amplifiers. The gain of the amplifier is maximum at its resonant frequency. 5. Series and parallel resonance circuits are used in induction heating.